In this video, we are going to solve the simpler type of riverboat problems going straight. So what I mean by straight is that instead of them going off at an angle, instead of them having a heading, it's called, they're facing in a direction that is straight across the river. So number 1 says, a motorboat traveling 5 meters per second east encounters a current traveling 2.5 meters per second north. A, what is the resultant velocity of the motorboat? That means what is the velocity relative to the Earth, so relative to something that is technically stationary. B, if the width of the river is 80 meters wide, then how much time does it take the boat to travel shore to shore? What distance does the boat reach? C is what distance downstream does the boat reach the opposite shore? So, we're going to start this normal problem-solving way by visualizing it. Let's zoom in a bit here. The current, let's draw the current first. The current is traveling 2.5 meters per second north, and the boat's velocity is 5 meters per second east. And then let's draw the actual banks of the river. Okay, so the boat, its heading is this way, and the current is going that way. The first part of the problem asks, what is the resultant velocity? So basically what's going to happen is the velocity is not going to be 5. This 2.5 meters per second is going to make it so that the velocity is actually that way. So it'll push it further downstream. That will affect both the magnitude and the angle. This line here will be the magnitude. So the magnitude, and we're going to use notation here that might be confusing at first. So the magnitude of the boat relative to the Earth, BE, is equal to the square root of 5 squared plus 2.5 squared. And you should get 5.59 meters per second. Now we still have to find the angle. In this case, we want to keep doing our thing of finding the angle that's relative to the horizontal. So the angle will be the inverse tangent of this over this, opposite adjacent. And you will get 26.56 degrees. What are our direction words? Well, this line is north of east. So that is part A of the problem. Part B asks us, if the width of the river is 80 meters wide, how much time does it take the boat to travel to the opposite shore? This looks kind of confusing at first, but it's actually quite easy. So this distance is 80 meters. And so this would be technically how far it goes in the x direction. And then 5 meters per second is its velocity in the x direction. So all we have to do for that is our 9th grade equation for speed, v equals d over t. If you solve for time, you get d over v. In this case, d is equal to 80, and velocity, again, don't use this velocity. The velocity in the x direction is 5. So there, you will get 16 seconds. So here is our answer to part B. Part C asks us for how far downstream does the boat land. So obviously it's going to kind of get pushed off to the side like that, so it'll end up downstream. Well, we know how long it takes the boat to cross the stream. We just figured that out in Part B. And we know at what speed the current is pushing it down. So again, we use our 9th grade equation for speed. We solve for distance this time. The speed, in this case, again, we want to find out how long it takes or how far it goes downstream. So 2.5. Multiply that by the time, which we calculated in Part B, and you should get 40 meters. And that's problem 1. All of the problems are pretty similar, but I think it's worth doing them all so we can get practice visualizing. So problem 2 says, and I changed it a little bit, a motorboat traveling 5 meters per second north encounters a current traveling 2.5 meters per second east. We want to find the same things that we found in problem number 1. However, we have to visualize it a little bit differently. In this problem, the current is traveling east. So the current is traveling east, 2.5 meters per second. And the motorboat is traveling north, so that would be that way. It's 5 meters per second. So, and here are the banks of our river. So again, if the boat is originally headed that way, then the current is going to push it downstream like that. So we want to find that. Again, this is the velocity of the boat relative to the Earth. And it's actually going to be the same answer that we got for Part A of the previous problem. So 5 squared plus 2.5 squared is equal to 5.59 meters per second. However, the angle is going to be different. If we draw, so basically here's our triangle. So that's 5, that's 2.5. Again, we want to find the angle that's relative to the horizontal. So we are looking for this angle here. So the angle is going to be equal to the inverse tangent of opposite over adjacent. So 5 over 2.5. Again, that's just the y component over the x component. And you should get (63.43 degrees). And again, this is north of east. So that is part A of the problem. Part B of the problem asks if the width of the river is 80 meters wide, then how much time does it take the boat to travel shore to shore? So again, this distance is 80. And we know this time it's the y component that we know. So we know that it wants to go in the y direction 80 meters, and the y component of its velocity is 5. We can just use our 9th grade equation for speed, rearrange it to solve for time. The distance is 80. The speed is 5. Again, we get 16 seconds. The next part of the problem asks us basically how far downstream the current will push the boat. Again, we want to use our ninth grade equation for speed, rearrange it for distance. In this case, we want to find out how far it travels in this x direction, and we know it's x component of the velocity. It's 2.5. We figured out the time in part B of the problem. So again, it ends up downstream 40 meters, but the river is oriented in a different direction. So in number 1, it would be 40 meters east. No, I'm sorry, it would be 40 meters north that it ended up. And then in this problem, it would be ending up 40 meters east from where it started. Right, we've got one more problem. So, a motorboat traveling 6 meters per second west encounters a current traveling 3.8 meters per second south. And we want to do the same types of things we did for the last two problems, except in this problem, the width of the river is 120 meters wide. So in this problem, the current is traveling 3.8 meters per second south. So let's draw that first. Here's the river, and we got 3.8 meters per second south. And let's draw our river. We know that that's 120 meters wide. And we know that the motorboat is going to head in that. No, it's going to head that direction because it's heading west. So it heads 6 meters per second that way. So, actually I meant to draw the vector up here. Sorry about that. So basically, the 3.8 meters per second current is going to cause the boat to go in this direction. So for part A, we want to find the velocity of the boat relative to the Earth. So the current's going to also cause the boat to go a little bit faster because, it's changing the direction. So we want to find the hypotenuse of that triangle. It's going to be 6 squared plus 3.8 squared inside square root. And that should be 7.1 meters per second. Now we still want to find the angle, and we want to find the angle relative to the horizontal. That's going to be this angle here. Let me actually redraw that real quick to make it a little bit clearer. So here is our 6. Here is our 3.8. And then that's our hypotenuse. We want to find this angle. So the angle is going to be equal to the inverse tangent of opposite over adjacent. So 3.8 over 6. We will end up with 32.3 degrees. And what direction word should we use? Well, this direction is south of the western line. So we want to write south of west. All right. Then part B asks us, if the width of the river is 120 meters wide, how much time does it take the boat to travel from shore to shore? So again, that's 120. So we know how far it travels in the x direction, and we know its speed in the x direction. It is 6. So again, we use our 9th grade equation for speed, Rearrange for time. Our distance is 120. Our speed is 6. And you should get 20 seconds. Then for part C, we are asked, what distance downstream does the boat travel? So again, the current is going to push the boat that way. So how far downstream does it land? Well, we know it takes 20 seconds for it to reach the opposite shore. We're trying to figure out how far it goes in this y direction. And we know its speed in the y direction. So again, we use our 9th grade equation for speed. Rearrange for distance. The speed is 3.8. The time we calculated in part B, it should be 76 meters. Let me circle my final answer there. So I hope you know better how to do these types of problems now.